Good day once again. I'm Mr. Senator, the engineering mathematics tutor. We are going to continue with the complex numbers as we are going to do question number 2. As I said, I'll play around with the numbers, which is very important. You must know how to solve the questions. So I'll just teach you, I'll just show you the methods on how to solve your assignment. So you just need to pay attention, take your time. I'm asking for your favor again, guys. Can you kindly subscribe to my channel so that I can post more videos on this? Okay, thank you. Let's continue. From a question 2.1, we are going to do question 2.1. Since we are focusing with our complex, we are focusing with the complex numbers here. So today we're going to talk about there's what you call a polar form. A polar form. And your exponential form. Yeah, so since you know previously from my previous video, I did try to explain the concept of complex numbers, that you are having a real number and an imaginary number. For example, here, this one is the basic form of a complex number. It's having a real number and an imaginary number like this. So I can give an example here. What I'm trying to say here, let's say for example, we need to change this one into a polar form. So you must know how to convert from this state up to polar form. So your polar form will be like this. Your polar form will be this way. Is going to be Z is equal to R. Then your R, you know that your R represent, you must know that your R, it will represent your modulus. So it's R. The next, it will be that opening bracket is cos theta plus, then imagine your imaginary sine theta. So that is your polar form. So you must know how to convert from this state here. That one is the first one that I stated. That one is, it's your rectangular form. So you need to know this one equates a rectangular form. Okay, the first one there, it's a rectangular form. Then the second one, we call it, it's a polar form. So as I said previously, you must know how to calculate your modulus. So this R here, it represents your modulus. That is the thing which is very important that you must know. And I hope you know how to calculate your R from, you know how to calculate your modulus from the rectangular form. We did it from the last video. Then that theta, that angle is the angle from the x-axis. So you must know how to find that angle. And that angle, they can call it an argument, as we did it from last time. So that is it. So that one, the first one is the rectangular form. Then that one is the formula for polar form. Then the lastly, we go to exponential form. So exponential form will be it will be written like this. It can be R, then E, then we can say I theta. Yeah. So as usual, your R there, your R represent your modulus. You know how to calculate the modulus. Then that theta is going to be your argument, and which is very important here. For this one here, you must know that that theta it must be in radians. So that is the thing that you need to understand about when you are dealing with it. When you are dealing with this exponential form, your theta must be in radians. So here is your formula. So you must know how to convert from rectangular form up to exponential form. I think we are going to do this at the time, but now I need to focus with your assignment. So we are going to start with 2.1. So I'm going to explain it bit by bit so that you can able to solve your question. Since I said I'm going to play around with the numbers, I'm not going to use the numbers as it is in your assignment. So you must make sure you understand how to solve the question. So let's move on. So number 2.1 here, we are given if they say if z1 is equal to, we are given z1 here is equal to, okay, your z1 is e, then exponent 1 minus j pi over 2. It's e 1 minus j pi over 2. As I said, I'm not going to use these numbers as it is. So I will just change the numbers, which is very important. You just need to know how to solve the question. So as for me, as for my assignment, your z1 is like this. I'm going to change your z1. I'm going to say my z1 is going to be e to the power of 1 minus j pi over 3. I'm going to use pi over 3. So let's do it. So here I'm going to say 1 minus pi over 3. That is my z1. Then z2, you are given in z2. Your z2 here, as you are given, it's 4 e. Let's say it's 4. Okay, it's 4. Then this e, you know that e, you know what does it represent? E to exponent j is the imaginary 3 pi. Okay, sorry. Okay, 3 pi over 4. So here I'm just going to change it here. My z2, I'm going to have I can say 5 e j 3 pi, okay, 3 pi over 4. I'm going to change only this radius there. I'll just use 5 there. So now the question is saying find z1 over z2 and give the answer in polar form. I already gave you the symbols. I already showed you which one is your polar form, which one is your exponential form, and which one is your rectangular form. So for this one, since you are given exponential form, we need to convert this exponential form to what? To polar form. So that's the thing which is very important for this question. So let's move on. So what is going to happen here? We are going to divide. Let's first divide first. Since we're having z1 and z2, so we are looking for what? For z1 divided by z2. So before we divide, I'm going to show you the basics. When you are dividing in the exponent, which rules do you apply? Okay, let's move on. So the basics that I can tell, let's say you are given your z1, which is the exponential form. Let's say it's r. We're going to say it's r1 here, e, then I theta. You know, I represent imaginary, or you can write it as a j. It's fine. Then let's say z2. Okay, z2 here. It's r2. Let's say it's another modulus r2 multiplied by e, then I theta. Okay, let me be specific here. Let's say your theta on the for Z1 is theta 1. Your theta for Z2 is what? Is theta 2. To show that they are different angles. So what you must know here is that when you are dividing, if it's Z1 divided by Z2, you are going to say equal to, you take your Z1, which is R1, E, I, theta 1, all over R2, then E, I, theta 2. So what you must know, the basics, the rules that you must know, that you need to apply, which is very important, is that whenever you are dividing your exponent, okay, let's start with our modulus. Our modulus is R1 divided by R2. So which means therefore we just divide those numbers. It will be your R1. My space too small here. Okay, let me just use the top part here. Yeah, let me use the top part. Okay, I'm going to write the top part here. Let me just leave out this part here. We are focusing on this part. So let's move on. I'm going to use the blue color. So which means what I said you first divide what? You first divide your modulus. So your modulus is going to be R1 divided by R2. The next, since we are dividing, what you must know, when you are dividing, you subtract your exponents. So which are your exponents? Say now we're going to say E here. My exponents here, it's I theta 1 and I theta 2. So you subtract when you are dividing. So whenever you're dividing, you subtract your exponents. So which one is your exponents? It's going to be your I theta 1 minus I theta 2. So that is the thing which is very important when I divide. So if we move on with this formula, let me wrap this part. I hope you did copy it. So it's going to be equal to, which means your R1 over R2 is going to be E. Then we can factor out your I. So which means your I, which is your imaginary number, which is theta 1 minus theta 2. So that is the thing which is very important when you are dealing with exponentials. When you are dealing with exponential form. So when you are dividing, you divide your exponents, you divide your powers, then you divide your modulus. That's the thing which is very important. Then I want to give you another thing which is very important. Let's say if you are multiplying, it can be Z1 multiplied by Z2. Yeah, since my Z1, I say it's E I theta 1 multiplied by E I theta 2. So, oh, sorry for this, I'm forgetting this R here. This R, yeah. Let's say it's R1 and R2. Since I said your Z1 is this one and your Z2 is this one. So when you're multiplying, what you do, you multiply your modulus first, which is R1 multiplied by R2. Then you get your answer. The next, if you're multiplying, now since you're multiplying, you add your exponents, you add your powers, which is what? I, let me use different color here. It's I theta 1 plus I theta 2, which means your final formula is going to be R1 multiplied by R2. Yeah, R1 multiplied by then E. Yeah, since we're adding our exponent, which one is a factor here? You can factor out your I. So it will be theta 1 plus theta 2. Now this is your final formula. So this thing is very important when you are dealing with these exponential forms, when you are dividing and when you are subtracting. I mean, when you are dividing and when you are multiplying, you must know how to apply this thing. It's very important. So let's go back to our question. Since I said for your question 2.1, yeah, I'm focusing with your question 2.1. My Z1 here, I said my Z1, let me write again. My Z1, it's E exponent 1 minus J pi over 3. Then my Z2 is equal to 5e j 3 pi over 4. Yeah, as I said, I'm just going to play around with the numbers. So here there's the question is saying let's find what? Find z1 over z2 first. Then after finding z1 over z2, give the answer in the polar form. So our first step that you can do here, let's first find our what? Our z1 over z2 using the exponential forms which are given. Then the answer that we're going to get, we need to convert that answer of z1 over z2 to what? To polar form. So as you can see, the question is having 3 marks. So let's first look for our z1 over z2 using those exponential forms. Let's do it. I already showed you how to simplify, how to divide exponential form, or how to deal with them. Let's move on. Yeah, since my z1, so I'm going to say my z1, I'm now dividing now. My z1, I said, is what? It's e exponent 1 minus rej pi over 3, then all over your z2 I said it's 5 e j, then 3 pi over 4. Yeah, as you can see, I want you guys to see something here. If you check your numerator there, that numerator, your e, do you see that there's no, it's like there's no what? It's like there's no modulus. If there's no number there, which means you must know that there's what? There's already 1 there. So you take it, it's a 1. You know this, it's mathematics. So let's move on next one. So which means, as I said, from our laws, if you are dividing the exponents, you first divide your what? Your modulus. So my modulus on my numerator is 1, then the modulus on my denominator it's 5. So I'm going to divide the modulus first, which is 1 over 5 first here. Yeah, let me use different color here. Then I'm going to say e. Yeah. Now I'm going to divide my exponent, which is your powers. Yeah, the exponent on my numerator it's 1 minus j pi over 3. Then the exponent on my denominator is j 3 pi over 4. So let's do it. Let's subtract since we are dividing. So I'm going to say 1 minus j pi over 3. Since we are subtracting, then we say minus j pi over 4. Yeah. So here what I'm doing here, I'm dividing my z1 over, I'm dividing z1 and what? And z2. Yeah. So let's move on. Since we are subtracting our powers here, it's 1 over 5 here, then e. So we just need to subtract for the like terms. Which are my like terms here? My like terms is that j pi over 3 minus j 3 pi over 4. You can use a calculator there. So it's going to be 1. Okay, 1 minus, okay, if you subtract your like terms, which is, you can say pi over, using calculate, you can say negative pi over 3, then minus 3 pi over 4. Yeah, what do you get here? You get negative 13 over 12. 13 over 12 pi. Now this one will become your expression for what? For z1 over z2. Let me wrap this part here. I hope you did copy it. So which means we are going to say my z1 over z2 is this one in exponential form. This one is in your what? It's in exponential form. But you just need to proceed, guys. How do you proceed? You need to proceed to what? To a polar form. you must convert this one to a polar form. That is the thing which is needed here for this question. So how do you convert this one to a polar form, since this one is still an exponential form? But as you can see, this exponential form is not in the simplified, state. We need to simplify it. That's the thing which is very important. What you must know here is that your exponent here, usually on your exponent, you must only have what you call, sorry, yeah, here I think, let's move back here. There's something which is missing there. You must have, okay, yeah, I think here I do not write my J. We must write our J here. There's J here on my what? On your radian angle there must be J, please. You must rectify it here. Yeah, thank you. So please, your J must be there. Because as you can see, I was subtracting what? Like terms, which is what? Which is this one and this one. When you subtract, I get negative 13 over 12 pi. And there's that J. Please, don't forget to write that J. Please. Yeah, it was my mistake to miss it out. I'm very sorry for that. But let's move on. So what I was saying, since I'm going to rub here the top part here, since our what? Since our exponential form is not exactly in this state, you know, your exponential form must be in this I, or you can say, let's say J, okay, J theta, which means your exponent, your power there, we must have theta and J. If you check your what, yeah, like the basic exponential form. So if you check here, can you see here, I'm still having 1 minus J. It's 1 minus J. I'm not having only what? The angle and J. So on your, as your power, what you must know is that you must only be left with what? With that J and theta. So our focus now, which means we only need to be left with this part only here. Like this one. Which means we must only be left with what? By, maybe you can say, negative J 13 over 12 pi. That is the thing which is very important about this. So this thing you must put it in your mind. It's very important. You need to put it in your mind. If you are not understanding what I'm trying to say here, please, you are free to come to my inbox so that I can explain more about this, or I'm going to post more videos on this one whereby I'm going to explain about exponential form, which are the complex numbers, and also polar forms, then rectangular forms. So let's move on here. So I was saying, so now let's try to get rid of the 1. We must get rid of this 1. Yeah. How do you get rid of that 1? Because for us to have that exponential, we must only, our exponent there, our power there, it must be only having J and theta. So let's do that. So we are now here, which is our Z1 over Z2 is equal to E, then 1 minus J, then 13 over 12 pi. So as I was saying, we must have our final answer here. Our final expression of the exponential form must be in this state. So let's do it. Must be in this state, J theta, like this. Yeah. So which means, you know guys, from mathematics, I can write this expression here, this one here. I can write this expression here like this. I can say E to the power of, yeah, remember there's 1 over 5 here. Not forgetting, there's 1 over 5 here. 1 over 5, please don't forget that. So I hope you know that I can write like this. I can say 1 over 5, okay, then E to the power of 1, then I can say multiply by E to the power of negative J 13 over 12 pi. I hope guys you did understand from mathematics, from the laws of exponents. Yeah, like the way I did write this one is the same thing from this part here. Yeah, but as you can see, your powers, it's 1 and negative j 13 over 12 pi. So you know that from laws of exponent, you can just add those powers. You still go back to what? To 1 minus j 13 pi. 13 over 12 pi. Yeah, I think you know this, guys. And remember that pi is going to be numerator. It's going to be a numerator. Yeah, so let's move on. So which means if it's like this now, I can say 1 over 5 times e. It's what? It's e over 5. Here you can just use your calculator. Now I'm now having e to the power of negative j 13 pi over 12. Now that is it. This one will become your final part of your what? Your exponential. Yeah, this one is the one which is very important, which means our r here, our radius, our r, which is not which is your modulus. Okay, your modulus is going to be your e over 5. Then your argument is negative j 13 pi over 12. So I'm just taking you step by step so that we understand how to deal with this concept. Okay, so from there, which is very important, this is not our final answer. The question is saying we need to change to what? To a polar form. We must change it to what? To a polar form. So we need to change this exponential form to a polar form so that we get our 3 marks. So let's move on. Let's keep on doing the question so that we can go to the final part of the answer. So now you must not convert this e. It's e over 5, then e to the power of negative j 13 over 12 pi. Yeah, like this. So we need to convert this to what? To a polar form. Since this one it's an exponential form, so let's do it. Our polar form must be in this state. It must be r, then cos theta plus j sine theta. So I think we already covered, but I said this one here, it's your r, but originally it will be like this. Your formula, it will be r e I theta, like this. I think you know this, guys. This thing is very important. So I'm already my r is what? My r it's e over 5. Maybe you can just use your calculator. You can just say e divided by 5. Then you get what? You just get your answer. That e, obviously there's 1 here. I remember, guys. Please don't forget to write that 1. So you can just say e to the power of 1 divided by 5. That one will become your r. Okay. Yeah, then okay, let's leave like that. It's fine. Then you say cos. Your theta is already given. It's, you see, it's 13 over 12 pi. That one is our argument anyway. But guys, since it's negative, I think guys, I think from the basics of math that if you say that cos negative theta is same thing as cos positive theta. I think this thing. This thing is very important. So which means if it's negative, I can just write 3 pi over 13 it's 13 pi cos 13 pi over 12, because it's the same. If it's negative or positive, you get the same answer. But for what? For sine, you must put that negative, please. So it will be sine negative 13 over 12 pi. Yeah, for sine, you just need to put a negative. So there's a negative here, guys. Remember, there's a negative there on that sign. So since there's negative, which means our final answer here is going to be like this now. That is going to be a final answer here. It's E over 5. You can simplify it using calculator. Let me use different color here. Okay. Yeah, okay, it's E over 5, then open bracket. Here it's going to be cos 13 pi over 12, then minus j sine 13 pi over 12, then closing bracket. This one will become your what? Your polar form now. This one will just become your final answer. But I think you can just, if you want to convert, you can just convert your angles. You can just convert your angles, that argument, to degrees. It's fine, which means you need to convert that radians to degrees. I hope you guys will remember, boss. I did talk about this thing from the previous video, to convert from radians to degrees. So this is how you can solve your question 2.1. So thank you guys. I'm kindly asking you to subscribe to my channel so that I can finish up revising your assignment and you will be able to answer your questions. Thank you.